Okay, so the edge of the kidney's up here. So this is cortex, and the structures we see, like there's one over here, here, all the things I'm pointing to, these are renal corpuscles. And the space that you see, well, it's a tuft of capillaries called the glomerulus, and the space around it is called the capsular space, and that's where you collect the filtrate. So if we look at this one, okay, there's a renal corpuscle, and that's going to be the glomerulus. And the space that you see right there, that's where you're going to collect the filtrate. You don't call it urine until it leaves the collecting tubule and dumps the product into the minor calyx. Up until that time, we're modifying it all the time. We're adding stuff to it, taking stuff away from it, so it's not urine. Once it leaves the collecting tubule, we can't do anything to it. Now it's urine. So all of the dark profiles here are nuclei of supracuboidal epithelial cells that form the proximal convoluted tubule and the distal convoluted tubule, but we're not going to try to differentiate those. So we've got a renal corpuscle over here, we've got one right here, and we can look around and find more because they're everywhere. Now what we're going to do is we're going to go to the medulla. The medulla is down towards the floor. And when we do that, we are going to look for a series of tubes that are all running parallel to each other, like these. And these form the nephron loop. So the fluid is going to run down into the medulla, and then it's going to come back up. And blood vessels are running right next to it. Since we have 1.25 million of these renal corpuscles in each cortex, and we've got a down side of the loop and an up side of the loop. There's 2.5 million of these tubes. They're all packed in there, and they're kind of U-shaped, they're body pin shaped, and right next to them is a special capillary that's called the vasa recta, and it's running immediately next to these tubes. So, it looks like a whole bunch of straws in a box. They're all running right next to one another. So this is just, as we look at this is just the renal medulla. It's where you don't have any corpuscles, and you've got a whole bunch of tubes that are running parallel to each other. Then we'll look at lung. It's not very satisfying to look at this because everything looks like it's just crumpled on, because there is no connective tissue in the wall of the alveoli. And all of these things that look like spaghetti here, they were the air sacs. So like, here was an air sac right here, and there's one on the other side, and there's one right here. We have 350 million of these in our lungs, and they sit sometimes this way, with the one next to it going that way, or sometimes like this. And I'll show pictures when we do a lecture on this. But these represent the crumpled alveoli, and we're going to look for a bronchiole. You describe a bronchiole because it has, and there's only one in here, and there it is right there. It has a pseudostratified ciliated columnar epithelium, and there's no cartilage in the wall. So the first set of tubes that we go into in our lungs have cartilage in the wall to keep the bronchi, primary, secondary, tertiary, and the first part of the bronchioles to keep it from collapsing when we create a negative pressure so we can take a breath. When we look at this, pseudostratified ciliated columnar epithelium, and I could go all the way around, but I don't need to. There is no cartilage in the wall, so it's one of the last tubes before you go into the alveoli. And if we come over like this, that's the only bronchiole in this particular slide, by the way. Okay, this is a little larger than an arteriole because you can see the green blood cells here. So the red blood cells, the hemoglobin has been stained green. So that's a little bit larger. But if we look over along these walls, we can see there's 1, 2, 3 red blood cells, green blood cells running right next to one another. Another one right here. So that would be like an alveolus, and that would be the pulmonary arteriole. So not yet a capillary, but small enough that we'll be able to exchange the blood. And if you look along, here's another one right here. And I mean, the arterioles are everywhere. And actually, I'll leave the slide out so if anyone wants to look at it, because when it goes through this projector, you kind of lose the coloration of green, although I can see it up here in these. But each one of these, this is like an alveolus, and on the other side, here's one right here. So 350 million air sacs we have in our lungs, so they're everywhere. But they just collapse because there's nothing to keep them inflated once the section is made. All right, so slides are a little bit scattered. And I'll continue to scatter them every time I show them so we don't just get into a pattern of looking at the same thing every time. And we're in the pancreas here, and the pancreatic islet we had seen before. And it's right here, but the bulk of everything that's there are going to be acinar cells. And this is where we're going to be producing our digestive enzymes. As I've stated before, you know, a key feature of this, the cells are pie-shaped, and acinus, this would be like an acinus right here. It's dark around the periphery because the nucleic acid in the nuclei and the nucleic acid in ribosomes for making these proteins stay with the dark portion of the dye. It's light to the center because we've made these zymogens. We've made these digestive, digestive enzymes, and the protein stays with the eosin part of the dye, and it stays pink. So, you know, there's an acinus, this is an acinus, that's an acinus, here's another one right here, and that's where we produce our digestive enzymes.